Hello everyone, welcome back to your own mathematics channel asm.geniusjunction. In today's video, we are going to cover 9709, paper number 3, unit 2, logarithmic and exponential functions. This is your video number 1, and topics to be covered in this video are going to be what is logarithm, logarithm to base 10, logarithm to base a, that is some unknown base, and after this we will do few questions to understand the concept in detail. Without wasting time, let's start. First of all, we will try to understand the definition of logarithmic functions. Logarithm is the inverse of exponentiation. Yes, exponential functions, which we already know. Logarithm is actually the inverse of exponentiation. If an exponent tells you what the number becomes raised to a power, then logarithm tells you what that power was. Mathematically, if we try to understand this concept, then suppose if I write b with the power as y equals to x, and if this is your exponential function, then if we try to convert this function to logarithmic function, then I'm going to get log of x with base b equals y. So here we have converted exponential function to logarithmic function, right? Now many students ask me that why we actually needed this concept. So now the question arises, why we actually needed the logarithmic functions. We need logarithmic functions because these functions helps you to turn complex multiplication questions into simple additions. We will understand how we convert these multiplication questions to addition, right? They turn complex divisions into subtractions, and yes, they turn exponents into simple multiplications. Let's understand how it actually works. Okay, so a quick understanding of how we solve a quick understanding of how we convert exponential functions exponential functions to logarithmic functions. So this is the heading for particular topic. Okay, so let's start. Suppose if I'm having 2 and I have an exponent of 2 as 3, so basically I'm going to get 8. This particular expression is your exponential function, right? This is your exponential function. Yes, so now we will convert this exponential function to logarithmic function. So I will write it as log of 8 with base 3, sorry, with base 2 gives you 3. So here I have converted a simple exponential function to logarithmic function. Now what we need to understand is what this particular expression means to say. So if we analyze the things, exponential functions tells us what is 2 raised to the power of 3. Try to understand this. I have written 2 with the power 3 and the answer is 8. That means exponential functions tells you what is 2 raised to the power 3 and the answer comes as 8, right? Now we will try to understand what a logarithmic functions is trying to convey to us. A logarithmic functions tells you how many 2's do I multiply to get 8. So in this expression, the question comes as how many 2's I need to multiply together so that my answer is 8. How many 2's should I multiply together to get 8? And the answer comes as 3, because if I multiply 2 3 times, I will get 8. So how many 2's do I multiply to get 8? This is basic understanding of exponential function and logarithmic function. We will understand this concept, that how we converted this exponential function to logarithmic function afterwards. So now we have reached on next topic of this video, that is graph of logarithmic functions. So now we have reached on the next topic of this video, that is going to be graph of logarithmic functions. We will understand how a logarithmic function and exponential function are actually connected to each other. To understand this thing, I have an expression, that is y equals to 10 with the power xx, right? So let's assume that this is your function f. Okay, so if I try to find the inverse of this function, I will write x is equals to 10 raised to power y. First of all, I will swap the variables. So now if I try to convert this expression, I will get y equals log of x to the base 10, right? So here what I have done is I have written this expression in this form. Okay, so I will say this is actually my f inverse of x. So first equation is your function f of x, and second equation is actually representing the inverse of the function. That's the reason I said in the first page of this video that logarithmic functions are inverse of exponentiation. Let's try to understand how these things reflect on the graph. So to understand this thing, I am drawing x and y axis. Okay, so quickly I will draw line y is equals to f of x. This y is equals to f of x is passing from origin, inclined at an angle of pi by 4. This is going to be the reflection of both the curves, because inverse functions reflect themselves in y is equals to x line. So first of all, I will draw the graph of y is equals to 10 raised to power x. After taking the points, we will get the graph of y is equals to f of x like this. It will intersect y-axis at 0 comma 1. So this is your y is equals to 10 raised to power x graph. Now comes the time to draw the graph for y is equals to log x with base 10. So as I said, these two graphs are going to be the reflection of each other in the line. So these graphs are going to appear on the graph paper like this. So here I can say that this white colored graph is actually y is equals to log x with base 10, and this graph is actually inverse of original graph, that is f. Okay, so after understanding the concept of graph of logarithmic function and how to convert logarithmic function to exponential function, we will go through with some basic details of logarithm with base 10. So logarithm to base 10 is also called common logarithm. Base 10 is most widely used base because our entire number system is based on 10. It is so common in many textbooks that if you see log without a little number written at the bottom, it is assumed to be having the base equals to 10, right? So notation for log written like this is logarithm with base 10. You can see that nothing is written over here. When nothing is written over here, it means it is representing 10. Okay, so this is log x with base 10, can be written in the short as log x. If nothing is written over here, it means that we are having a base which is equals to 10. The first point written over here is log 10 with base 10. When I said above that when nothing is written over here, it means that it is 10. So this is log 10 with base 10. Okay, so log 10 with base 10 actually becomes 1. Why it becomes 1? Because this expression is saying that how many times I need to multiply 10 to get 10, and the answer is 1 times. That's the reason we are getting answer as 1. You will understand this thing in with the help of this particular expression. This particular expression which is highlighted on the screen is asking how many times, how many times I need to multiply 10 to get 100, and this time your answer is going to be 2. You are multiplying 10 two times to get 100. Exactly same way, suppose if I'm having log of 1000 with base 10, so this particular expression is saying how many times you need to multiply 10 to get 1000, and your answer becomes 3. So general base can be written as a, and common base is written as 10. So whenever I will say common logarithm, it means that I'm talking about log of something with base 10. And if I'm asking general base, it means that it can be any number. If you want to convert a logarithmic function to exponential function, I can write it as a with exponent y is equals to x. And yes, so now we are having two expressions. General base y is equals to log of general base y is equals to log x with base a, that becomes a raised to power y is equals to x, and common log, that is y is equals to log x with base 10, and it can be written as 10 raised to power y equals x. We will understand how we convert these particular expressions afterwards. Yes, so now we are going to understand the concepts of logarithm by doing few questions based on this particular concept. Okay, so let's take few questions based on the concept of log to understand how we convert exponential functions to logarithmic functions. So first question says that convert 10 raised to power x equals 58 to logarithmic function, logarithmic form. So how I are going to convert this? This is base 10 with the power as x. So I will convert this particular expression in logarithmic form, and I will keep the base same. Now the question comes, how many times this 10 should be multiplied to get 58? So it becomes answer as x. Here I have converted this particular expression in logarithmic form. So here we have converted exponential function to logarithmic function, right? So we will do few more questions to understand this thing in a detail. Let's take one more question. Question says convert log x with base 10 equals 3.5 to exponential form. Here what I'm going to do is I will keep the base same, so I will write base as 10, and equals to what is written as answer will become the exponent, so it will become 10 with raised power is equals to x. So in this question I have converted a simple logarithmic form to exponential form. So here we can see from question number 1 and question number 2 that we can convert exponential form to logarithmic form, and we can convert logarithmic form back to exponential form. Okay, so we will do few more simple questions to understand these things. And so here we are doing one more question. Let's see, log of 10,000 with base 10. So the concept which we have studied is saying that how many tens should be multiplied to get 10,000. So we can solve it like this, and your answer is going to be 10 should be multiplied 4 times. So your answer for the given question becomes 4. So I will remove these hundreds from in between. I will write 4 over here. In the same way, suppose if they ask you log of 1 lakh. Now the question comes log of 10 lakh with the base 10, and my answer is going to become 6. Suppose if the question comes what is log of 0.0001 with base 10, I will write this particular expression with log of 10 with power as minus 4 and base will remain 10. Now this power 4 will come on that side and it will finally give me answer as minus 4. Okay, so here we have done few questions to understand the things. We will do few more to consolidate our understanding based on logarithm. So here I'm doing one question. Let's say question says log of 10,000 with the base 10 is equals to 4. Convert from logarithmic form to exponential form. So I will write base as 10 and answer given to us as power, and this gives you 10,000. So here I have converted this particular question to exponential form. Let's take one more example. Let's take one more example. Suppose if I am having, okay, so let's take one more example. Question says without using calculator. So here we have to use our basic understanding. Without using calculator, find the value. So first part of it, let's take log of 100 with base 10. So question says how many tens should be multiplied to get 100? You will say 2. So this was very simple. Let's take the other part of it. Log of 0.000. So this was a very simple one. So let's take one more example to understand the things. 10 root 10 with base 10. First of all, I will try to convert this 10 and half, because 10 root 10 can be written as 10 to the power 1 plus 1 by 2. Base will remain as it is. This will become log of 10 to the power 3 by 2. Base will remain as it is. Now this can be written as 3 by 2 log 10 base 10, which is actually 1. So final answer for the given question becomes 3 by 2. I will do few more to make you people understand how we are solving these questions. So let's do one more. Let's do C part. It is all these questions are based on the same concepts. That's why I'm marking them as ABC under this above headline of without using calculator. Okay, so this is log of cube root of 10 with base 10. I will convert this first of all. So I will write log of 10 with power as 3 and base 10, and finally I will get my answer as 1 by 3. So now we are taking one more example. This is log 100 denominator root 1000. And yes, so now we will solve this particular expression. This is log with base 10. Numerator is having the power of 2 and denominator is having a power of 3 by 2. So I will bring this denominator in the numerator. It will become 2 minus 3 by 2 and base will remain 10. In the next step I can write it as 2 minus 3 by 2 becomes 1 by 2, base remains 10, and then I can write this expression as 1 by 2 log 10 base 10, which actually becomes 1. So this particular expression will give you 1, and then we are left with the final answer as 1 by 2. Okay, so keeping the pace, let's do one more question based on the same concept. Okay, so now let's move on to next question to understand how much we have understood this. So question says that given that P and Q are positive and that 4 times log P with base 10 whole square plus 2 log Q with base 10 whole square gives you 9. Question says find the greatest possible value for P. In this question you can clearly see that you are given a equation, and in this equation we are having two quantities which are having a square with them. This is 4 times, let's say this is a square, and this is 2 times, let's say it is b square. Together they give you 9. Now they're asking you what can be the maximum value for this expression. So if two quantities are adding up and giving you 9, it means that if I put this expression equals to 0, then my final answer will be the maximum value for first expression. So I'm going to do it in the same way. I will put log q with base 10 whole square at coefficient 2 equals to 0. Once we put that equals to 0, we get 4 times log of p with base 10 whole square equals to 9. Solving this equation further, I can write log of p with base 10 whole square is equals to 9 by 4. Now we can remove the square from the left hand side, so we will get log p base 10 is equals to plus minus 3 by 2. Now we will take into consideration both the values, so I will write, so taking both the values we can solve log p with base 10 equals plus 3 by 2, or log p base 10 is equals to minus 3 by 2. Once we will solve this further, we will get p is equals to 10 raised to the power 3 by 2, or p is equals to 10 raised minus 3 by 2. So 10 raised to the power 3 by 2 gives me answer as 31.6, and p raised to the power minus 3 by 2 gives you answer as is equals to 0.16. So these are the two values for the given question, and this is the maximum value for p in this particular expression. Do not forget to subscribe the channel so that you can get timely update regarding the videos. Thank you so much. Have a good day.